Okay, what we're looking at here, my name is Sergio Garcia. It's Dr. Sergio Garcia. You know me as FinProf or statsprof, or maybe I am actually your professor. But what we're going to do here today is look through all the different steps in going through a multiple regression from raw data. What we have in front of us right here is a data set that is a price related data set for homes. This is in the Kansas City area. It's got like 2,000 data sets. Look at my total numbers over here on the right. I'm going to go a shift control down. I've got 21,000 observations. It's a bit 21,000 observations. It's a bit much. And so I'm going to I was going to chop this earlier, but I thought I might as well show you what the entire process looks like. So here we go. The first thing I'm going to do is I'm just going to grab the first 15 variables. All right, so the first 15 line, which is actually 14 variables. So first 15, and I'm going to grab these 14 observations. We can grab more if you want. It's just 14 is easy. Let's grab 20, right? 20. I go down to line 21 because there's 20 observations, because the first line is the variables. And I'm just going to do a control C or a copy, and I'm going to create a new variable set on a different sheet. Not a big deal. And then I'm going to start playing with these numbers. Make sure that this ID number is text. We're really not going to use it. And here's date. Here's the price. And what we're going to end up doing eventually is running a regression that has the price as my y variable. So we're going to do, this is going to be my y, and first thing we're going to do is like square footage will be my x sub 1, and then this will be x sub 2 or x sub 3 and so on, and eventually we'll get something like beta sub 1 x sub 1 plus beta sub 2 x sub 2 plus and so on. All right, so that's where we're headed. But I figured I might as well do the whole thing from scratch so you can see it. A couple of other things that we have here include square foot for living space, square foot of the lot, number of floors. We'll probably skip that one. We'll skip some of these. Condition, grade, square foot above. What is that? Square foot above. Maybe that's on the second floor. I don't know. Square foot basement. This is if it has a basement. We might include that. Year built. We'll probably include something like that. And then some of this other stuff might be a little more complicated than we're really going to worry about. We can do some lat long stuff later. But for now, we'll probably just do a multiple regression with about 3 or 4 of these. So what do we want to do first? The first thing I want to do is since we're in Excel, is I want to consolidate the data set to include only those things that I want to include. So what I'm going to do here first is do some really basic cleaning up. I'm going to make this bold, the variables, and I'm going to center them. I like to say a pretty spreadsheet is a clean spreadsheet, right? So a clean spreadsheet is a workable spreadsheet. So I'm not going to use date. I'm not going to use ID, not for this particular example. We might play with that later. So I'm going to delete that away. Prices on the left-hand side, that's fine. I'm going to keep bedrooms. Let me make this a little bigger here so you guys can see it. I'm going to keep bedrooms. I'm going to keep bathrooms, square foot living, square foot of the lot. I'm going to throw away floors, waterfront, view, condition, grade. I think we're going to keep basement. I'm not sure. I'm going to do a right-click on this after highlighting the entire column and hit this delete. If you hit the delete on your keyboard, you're just going to empty it out. I'll show you what I mean. Here's year built. I'm going to hit delete. It just emptied it, but the column stays. I need to do a right click. You know what? I want to keep year built, I think. Let's throw away basement space. I'll keep it. Year renovated. I'm not going to worry about that. And then instead of just hitting delete and making those go away, although this works here on the end, we're going to do a right click and hit delete, and it'll make the whole column go away. So our data set's a little easier to manage now. We have a small number of observations. We have 20 observations. Once you learn how to do this on this one, it'll be easy to do them on any observation size. We're going to change the price, and in this case, I'm going to turn it into dollars so that I know that it's dollars. Bedrooms will stay the same. All this other stuff will stay the same. Okay, so now I've got to do my hypotheses, right? So what do I think is going to happen when I do these? First, we're going to do a single linear regression on, say, square foot living, which we've done in another video. And we're going to assume that there is a positive relationship here. What does that mean? It means that if I graph all of these observations between square feet and the price of the building, we expect there to be a positive relationship, a line that goes up. As square foot increases, or goes this way actually, then the dollars and the value of the price also increases. And that makes sense, right? The bigger the house, the higher the price. So let's do that. If you haven't done this before, then you're going to want to go to data and do data analysis. And sorry, if you don't have data analysis, then you're going to want to hit File, Options, Add-ins. When I hit Add-ins, you get this big screen, and down at the bottom, you'll have this Manage Excel Add-ins. You hit Go, and you want to make sure you check the first one, Analysis Tool Pack. You do not want VBA. That's Virtual Basic. It gets complicated. Just hit the first one, hit OK. Every Excel will have this, or should, and when you come up to Data tab at the very top, you'll have this Data Analysis. We're going to go into Data Analysis. We're going to hit the regression. We're going to hit OK, and we're going to say that, oh, I got stuff here from before. Let's throw all this away. We're going to say that our first input range is going to be price. So I'm going to highlight price. I like to use Control-Shift and the arrow because it gives me the entire column. You can highlight it with your mouse if you want. That's completely up to you. I like to come up to the top of the variable. I like to grab the actual variable name. I'll show you why in a second, and highlight the entire thing so that my box says A1 to A21, and I'm going to hit my X range. My X range, we've decided it's going to be square foot living. Again, Control-Shift down, it grabs the whole thing, including the variable name, which is the label. See this little button right here that says labels? If I hit labels, you're telling the computer, hey, I've included the name of the variable in the label. I want you to create a new worksheet and call this guy housing single variable, or you know what, housing square feet, right? And hit OK, and we get this big deal. I assume you've already seen some of this. R square value is nice and high. I like that. There are 20 total observations. My F stat, let me switch this to 3 decimals. Will it let me? So I don't think that's going to switch, and that's fine. The point is this e to the negative 0.8 means that it's very, very small, 0.000000. I'll type it in, 0.00000008, which frankly is 0.00000, and we'll just live with that. So that's great. That's fantastic. All right. I think I can just switch that. I'm not going to worry about it. What I really want over here is the coefficients for intercept and square foot living. And what you'll notice is that the square foot living actually says square foot living. It doesn't say variable 1 or whatever it says first listing. And you want this particularly in a multiple regression scenario because we're about to add in, a couple of other variables here. We're going to have square foot lot, and we're going to have bedrooms and whatever. So it's kind of important. And we like that. Square foot living here again has the switch to variable. There it is. I figured it out. I don't know why I couldn't remember that. 3 variables are always nice. We like 3 variables. 3 decimals. It's just easier to read. There's my 0.000. That tells me I have a good variable, and we're good to go. All right. So that is the single regression. Let's go back to our data. And this is how we're going to do multiple regression. So we're back in our data. We've got price and bedrooms, and again, price is my Y. Let's go to data and data analysis, and we're going to run the regression just like we did before with our single regression. You'd actually see that the answers are here, or the results are here. A is still my Y variable, so that's great. And the only difference we're going to do here is that because we've lined them together, we can include them all together. I'm going to include 1, 2, 3, 4, 5, 6 different variables, and now I'm going to Control-Shift down and highlight the entire box. So I am highlighting from B all the way to G, and then those results, and then the observations all the way down for the same number of observations. A1 to A21 is my Y. B1 to G21 include all my X's. And you can see how it's important at the beginning of this process to eliminate the ones you don't want or group them together so that when you run the regression, they're all in one big pile. All right. I hit OK. Note that labels are still included. housing square foot. Let's call this model 1. And we hit OK. And so now we get this nice, beautiful regression with all multiple stuff. To start at the top, R squared is 0.88, still good. Total observations are 20, still good. F stat, let's switch F stat to comma, 0.00. I like that. Everything looks nice. And now I have all of these different variables with their coefficient. So let's highlight these real quick. And let's make them all 3 decimal places. I can't do that for those. So let's make these 3 decimals. And we like 3 decimals because that's just the academic standard. Okay. If you want to make them less because they're coefficients, I'm okay with that. We're certainly going to do the p-values at 3 decimals. All right. So the intercept we're going to ignore. The bedrooms, positive. Bathrooms positive. So more bedrooms means more higher price. Bathrooms at higher price. Look at that slope. 107,000 compared to 34,000 bathrooms. An extra bathroom means a whole lot more money. All right. So when you're thinking about redoing your house, square foot living is positive. Square foot lot is positive, but not as much. Square foot basement is positive, and year built is negative. What does that mean? It means as years go up, price goes up. No, it'd be the other way around, right? As the years increase, or the year that it's built increase, it actually decreases the price of the price of the home. And so that's an interesting, discussion to have later. Why is that? You might argue that older neighborhoods are more established, newer construction's not as great quality in Kansas City, or whatever. All right, so most of this stuff made sense. As they go up, we increase in value. The other one that may include a little discussion is the year that it's built, and that's fine. But more to the point, we need to go over here and look at the p-values for these guys. And the p-values are not good. One of the reasons the p-values here might not be great is because we don't have a lot of observations. So none of these p-values are less than 0.10. This one comes real close, but none of them are certainly less than 0.05. So we're going to start to do what we're going to call a reverse stepwise process. We're going to take this square foot basement because it's got the biggest p-value out of all of these other p-values, and we're going to throw it out. Okay, so we're going to take square foot basement and we're going to throw it out of our model. So let's before we do that, let me show you how to do we might as well build a final table as while we're at it. So let's go to sheet 5. I'm going to call this final table. Let's build a final table while we're at it. We go to our housing model 1. I'm going to go ahead and grab these, the name of the variable and the coefficient, and I'm going to go to my final table. Let's just go ahead and build it because we're here. Copy paste. Wow, way small. Let me make that big for you. So that's the intercept. Let's make it a little smaller. And I'm going to go ahead and add a line at the very top. Let's insert a line, and let's call this model number 1. Model number 1. Enter. So that's not what I wanted. Let's change it back to text. Again, model number 1, since we're in text. And we'll center that. Yes, I know. Yes, I know. Yes, I'm aware. Okay, great. The intercept and the deal. So we'll leave these here. You can go back and include stars here if you know what the stars are for the different levels of significance. But really, none of these guys are significant, so we're not going to include stars. Let's go back to our data. And we said we were going to throw out the basement, right? Let's go back to the model. Which is the biggest one? This is the biggest one. It was the basement. So let's go and throw out basement. So we're going to do basement, right-click, delete, and we're going to run our regression again. Data analysis, regression, okay. And this time, I'm not going to mess with it too much. I'm going to come in here. I've already thrown it out, so it goes to F. So I'm just going to come over here and change the G to an F. Oh, man, I messed that up. G to an F, B1 to F21. Hit OK. There's a problem with this formula. What's wrong with this formula? Oh, this is model number 2. Very good. Hit OK. There's a problem with this formula. What am I doing wrong here? $2 signs in the middle of my text. All right. The point is I'm going from B1 all the way down to whatever. Oh, I see, because I click on the screen. All right, no problem. There's our regression. Come back up. Here's my R squared is 0.87, 20 observations. I have a good F. I like that. And now that I've run this one, again, I can look at my coefficients. My coefficients are all positive except for the last one. That's fine. And I look at my p-value. Again, it's hard to read the p-value without modifying this to 3 decimal places. So let's switch it to 3 decimal places. Okay, this guy gets closer. That's my intercept. I really don't care. This guy gets closer. Square foot living is significant, right? This is significant because it's smaller than 0.10. I'm saying at an alpha, let's do this. At an alpha of 0.10, this is smaller than that one, so that's good. At an alpha at 0.05, this guy is not smaller than 0.05, so that doesn't include. Alpha at 0.01, this is not smaller than that one, so we can't include there. We can say we are significant at 0.10, so this guy's going to get 1 star. And only 1 star. The rest of these guys are not significant at 0.10 because they're bigger than 0.10. So that's okay. That's all right. We're going to run another one, but let's copy this. I don't really need. You got to be careful here now, right? Because I have these kind of all over the place. Here's my final table. You got to be careful here. Bedrooms, I can copy over. Square foot lot, I can copy over. I can Control C. Actually, I should include the intercept. Control C and copy this one here. But now year built isn't in the same place. And so what I want to do here is show the second model. All 3 of these or all 5 of these go straight to where their value is, but year built is over here. There'll be nothing in this cell, and this 172549 needs to go into this cell. Okay, because we're describing the same variable, we're just going to do it in the second model. Let's go here and Control V. We will call this model number 2, and let's give it a different highlight. Let's make this one orange. Oh, that is really ugly, actually. Let's make it blue. All right, and I obviously don't need this anymore. Okay, great. So now we're kind of building a model. Oh, but one of these was significant, right? So let's go back to housing model 2. Which one was significant? Square foot living was significant. All right, so here's square foot living. And in here, first of all, let me turn this into, remember, a pretty spreadsheet is a strong spreadsheet, right? 1 decimal, square foot living. I want to come to the back of this. Oh, man, come on. I want to come to the back of this guy, and I'm going to give it 1 star because it is addressable at the alpha equals 0.01. So that guy gets 1 star. All right. So now I know I can easily see that this is 1 star. It's good. Okay, great. Let's go back to housing model 2. Which is the biggest p-value here? Bedrooms is the biggest p-value. So let's throw that one out and see what happens. We go back to our data. Bedrooms is the biggest p-value. Let's do a right click and delete it. This is called reverse stepwise because we include all the variables, and then one at a time we're going to remove the variables until we get the most parsimonious model. What does parsimonious mean? It means easiest. It means most efficient. It means not complicated. We run the regression. Again, all I'm going to do is simply modify the F and make it an E to include just those columns. Labels is good. New worksheet, yes, but I want this to be model number 3. I hit OK. I get another model. Same thing again, right? R squared looks good. 20 observations. Significance is good, right? We can change this. 0.0. The significance of the entire equation is good. My coefficients are positive, negative, just as expected, just like we had before. And my p-values appear to get better. Let's take a look here. All right. Good. That one's nice and small. It's better than 0.05. This one's nice and small, better than 0.05. This one's 0.04. Very good. Okay, great. But I do have one more to throw out, so I'm going to throw it out here in a second. But this one looks nice. It looks very clean and parsimonious. Let's copy these guys and take them over to our final table. Again, I'm going to just paste it over here on the side for scratch. Bathrooms, square living, and lot happen to be together. Bathrooms, square living, and lot. So I can cut and paste those there. Year built, again, remains negative, but it is way down here at the bottom, so I'm going to put it down there. And which one of these was significant? Well, let's go back to model number 3. Let's see. So this guy is significant at 0.05, right? This guy is 0.05. This one is significant at 0.05, which means it's smaller than 0.05. This is significant at 0.05. This is significant at 0.05. If it was below 0.01, less than 0.01, then we could say they're significant at 0.01. That would be 3 stars. They are not. These guys are going to be 2 stars, all of them. Okay? So we go back to sheet... Sorry. We go back to the final table. Wait, no, they're not all significant at that. Model 3. Everything except square foot lot. Okay. Go back to final table. This guy is a mess. Whoops. 1 point. Let's go to 0.1. That's actually 0.2. He gets 2 stars. Square foot living. Same thing. We'll delete all of this stuff. He gets 2 stars at the end. This guy is not significant, so we can just leave him alone. Although I don't like that many decimal points. Do something like that. Or less. It doesn't matter. This guy is significant, even though it's just a year built. 0.0123. And what am I missing? I'm missing the intercept in this one, right? How come I didn't copy the intercept? Let's just copy the intercept real quick. 4,000. Control C. The intercept goes up here. And it is also significant at 2 stars or 5% alpha. All right, let's do one more because we're almost done here. A little more than we expected, but let's do one more. So we can delete all of this. Delete. You can go away. I'm going to double click this to make them on the same place. And these guys, they're often right aligned. So you might want to right align those. It makes it look a little nicer. Okay, model 3. So which one of these is not significant? Square foot lot is not significant. So we're going to go to sheet 2 and we're going to take square foot lot and I'm going to right click and delete it. Run my regression again. Data analysis, regression. And same thing, I'm just going to delete the E, include a D. Labels is good. This is model number 4. Hit OK. And same thing. R squared looks good. R squared looks good. Significance of the variables of the equation looks good. Positive, negative, just like before. All my p-values are small, so I really like this. All right, let's copy paste these guys over to our final table. Right? Let me put it over here. Let's call this model number 4. This is going to be our last one. The intercept is 38. Actually, I could cut it out and paste it there. Bathrooms and square living are together, so I can do them both at the same time. Paste them here. Year built, cut, and paste it here. Let's go ahead and delete this because it's starting to get a little confusing. And let's go back to model number 4, and let's find out which ones are significant. All right. So in this case, this is significant at 0.05. This is significant at 0.05. This guy's actually significant at 0.01. Right, so this guy's significant at 0.01. He's going to get 3 stars. 1, 2, 3, while everybody else gets 2. This dude is significant at 0.05. The rest of them are only going to get 2 stars. So that's square foot living. and that's going to get 3. So let's go back and do that. Final table. Everybody gets 2 stars. Delete, 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 delete. I don't need the decimal. 1, 2, enter, enter. You can also hit F2 here, and that'll get you into the edits. That's really big, so it just needs 2 stars, and that's fine. Square foot living had a P value that was really, really small. So let's keep the 7, and then just do 1, 2, 3. Okay, and then this guy, same thing. We can delete everything and give him only 2 stars. We found a typo. Yeah, correct it. Oh, no, 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 no. 0.0. I don't know what it was, but it doesn't matter. 1, 2. There we go. Do I want to accept the correction? I do not want to accept your correction. There's no calculation here. All right. Again, these guys, no, I don't want to accept. No, I don't want to accept your correction. Oh, you're killing me. All right. So let's do, I'm going to do this one by hand. Negative 1997, 12. Okay, there we go. Again, these guys are, it's very common to have these guys do a right, to be right aligned, so all the stars kind of line up. Make a little space for it, and then you can start cleaning those out. Right click and delete this guy just to make it nice and clean. And now I have my 4 models. Let me make this a little bit bigger so we can see them really nice and clean, and let's talk about these. In model number 1, these guys are not significant. I shouldn't use the X, actually. Not significant, not significant, not significant, not significant, not significant, not significant. It doesn't mean that there's not a relationship here. These guys clearly have a relationship. Each one of these values has a slope to it, and you can see that this is positive, 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 and this one is negative. So the relationship still exists. We just as statistics, so you can stand up and say, hey, look, as the total number of bedrooms goes up, let me switch to a different color just because we're doing the same thing. The price, to a different color, thank you. The price of the house also goes up. All right, so that's real. It's just that it doesn't happen within the 95th confidence interval, which is our alpha 0.05. So, I mean, does it happen? Yeah, it happens, but it's not reliable enough to happen that we can confidently, confidence interval, say that the average of these 95% of the time will be within this mean. Okay, fine. So we take the biggest one and we take it out. So this guy goes away, score basement goes away, and we run it again. So there's nothing here. Now we find one level of significance. Okay, square foot living looks good, still positive, has 1 star. We like it very much, which is the next one, the bedrooms. Now the bedrooms is going to get thrown out because it had the biggest other one. This one goes away, this one goes away, and now we run it again. Significant, 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 not significant. We throw it out. Square foot lot goes away, this goes away. So we have nothing here, nothing here, nothing here, and now we have this guy, which we are going to call the parsimonious model. It is the most efficient. It is the best way to create predictability without having a superfluous number of variables. We don't have all this extra junk, right? We could do any one of these models. We could do, how do I clear this? We can do any one of these models. You can run them all. But we most often want to run number 4 because it is the easiest way to predict what's going on. In many of these cases, you'll also include our square value down here at the bottom, the number of observations, anything else that might allow you to better describe what the model looks like. But for the most part, the stuff on the top is where we focus the majority of our attention. I hope that has been helpful, and good luck.